welcome to the last installation in this series for now, because of course you're always welcome to request more videos, a redo of a video, etc. So yes, but for now this is the last question of the paper we've been looking at, IEB paper 2, November 2022. Question 14. Right, if 2 cos 2 alpha plus sine 2 alpha is equal to r cos 2 alpha minus beta, where r is positive and beta, did I say b or beta, is an acute angle, determine r and beta. Wow. I don't know. So I am inclined to expand this, not expand it, but to use the fact that cos of A minus B is the same as cos A cos B plus sine A sine B. Okay, because I see here that on this side I'm just dealing with 2 alpha, whereas on this side I'm dealing with 2 alpha and a beta, so it feels right to kind of get them split up like this. So let's see. So r cos 2 alpha minus beta is equal to r times cos 2 alpha. Hey, my 2's and my alphas are looking too close for comfort. Plus, oops, okay, so this is sine 2 alpha sine beta, and we are somehow ending up with 2 cos 2 alpha and sine 2 alpha. So let's see. So this is r cos 2 alpha cos beta plus r sine 2 alpha sine beta, and we're being told that these are equal to 2 cos 2 alpha plus sine 2 alpha. I'm just going to accept that my 2's and my alphas are going to be ambiguous. Okay, so I'm not convinced this is legal just yet, but I am seeing cos 2 alpha here, which makes me feel like the r cos beta is equal to 2, and I'm seeing sine 2 alpha here, and we can just scribble in an imaginary 1 over here, and that would mean now that r sine beta needs to be equal to 1 in order for this to hold. So this gives us simultaneous equations, right, where r cos beta needs to be equal to 2 and r sine beta needs to be equal to 1. So we can so I think that we can divide this equation with this equation so that we end up with a tan beta. So let me just label my equations. So equation number 1, equation number 2. So we have, if we say equation number 2 divided by equation number 1, we have r sine beta divided by r cos beta is equal to 1 over 2. And of course this is for all the places where so there are restrictions here. So cos beta can't be equal to 0, so that's all the places where tan is undefined, 90, 270, and so on. Right, but I'm going to be irresponsible and not write that. My r's are going to cancel out, so we have tan beta is equal to a half. And then, so that's first quadrant and third quadrant. So beta is 26,56 blah 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 plus k 180, where k is an element of the integer set. So now we know what beta is. Now let's find r. So r cos 26,56 whatever needs to give me 2. So r is equal to 2 over cos of that. Oh, hectic. Yeah, no, what am I doing? Okay, so first of all, this is where we're using, we're not doing general solution here. This is where why did I rub on my dots? We're using the fact that we've been told beta is an acute angle. So we don't need to consider the plus k 180 because then it wouldn't be acute anymore. Yeah, because, sorry, yawn. Plus 180 is going to make plus 180 is going to make it a third quadrant angle. Minus 180 also makes it a third quadrant angle. So, and anything beyond that is just getting further and further away from acute. So, right. So this is why we can just go right ahead and put it in here as a single value as opposed to my plus k 180 that would have complicated solving this equation, because then I would have had to consider all the possible values for beta, but we only have one possible value, which is that, given the information we're provided with anyway. Right, so we are saying I want to store this actually. So 2 divided by cos of that number. So it is going to be 2, 2, 4. And I'm going to store you 2. What's going on, guys? Hang in there, battery. Oh, it's the square root of 5. Is that what it is? Oh my gosh. So we don't even need this. You can just say the square root of 5. Right. I definitely want to check with the memo whether we're on the right track. And yes, we do end up with the same potato, which is fantastic. Okay, cool. So now, I'm definitely curious to see how the memo goes about it, because I'm feeling shaky. I would definitely have wanted to just double check our solutions in here, so not too late to do that. So that is root 5 times sine of that guy does indeed give us 1, so that's comforting. Okay, so now we're asked, hence or otherwise determine the maximum value of 4 cos squared alpha plus sine 2 alpha. So the sine 2 alpha is giving this to me. And then the 4 cos squared alpha, I feel like I need to connect to this somehow. So let's just see here. 4 cos squared alpha, and let's see, 2 cos 2 alpha. So 2 cos 2 alpha is the same as 2 cos squared alpha minus 1. I'm not using the one involving the sign because ultimately I want to draw a bridge between these two. So having the sign is just going to pasamisa me. Right. So the connection between these two is that this is 2 more than this, right? This is 4 cos squared alpha minus 2. So this is 2 units more than this. So I can figure out the maximum value of this by figuring out the maximum value of this and then recognizing that whatever its maximum is, the maximum of this will be the maximum of this will be 2 units more than the maximum of this, right? So let's just say that again slowly for myself. So we discovered that too enthusiastic, right? We discovered that 2 cos 2 alpha coming from here is the same as 2 times that, so replacing this guy with this. And if you multiply these out, you get 4 cos squared alpha minus 2, right? And so 2 cos 2 alpha plus sine 2 alpha, which is that expression over there, is the same as 4 cos squared alpha minus 2 plus sine 2 alpha, right? Or just to write that more prettily, it is that, right? We are looking for the maximum value of this. We can find that by finding the maximum value of this. So if, say, we find that the maximum value of this is -5, right, then we know that the maximum value of this will be 2 units more than that, because the difference between these two is 2 units. This one is 2 units less than this one. So if this one's maximum is -5, then this one's will be -3. It'll be 2 higher. Okay. We also know that this guy is the same as this guy. So we can find the maximum of this, and that will help us find the maximum of this. Okay, so we need to find the maximum of, and I'll replace the figures just now, r cos 2 alpha minus beta. Okay, and this is easier to find the maximum of because this is something whose graph we can draw, whereas this, we have multiple ratios going on. We don't really know how to draw that. Okay, so this is root 5 as we found previously, and the beta is 26,56 blah blah blah. Okay, so this is a cosine graph whose amplitude has been changed. Its periodicity has been changed as well, and it's also been shifted. I always forget there's a catch when you sketch a graph with both the periodicity and there's also horizontal translation, so I'm going to tread with care. So as usual, what I like to do with sketching my graphs is to start out with the very original graph, or in this case we're calling it alpha. Y is equal to cos alpha, right? So we have 0 degrees and 1, 90 degrees and 0, 180 degrees and -1, 270 degrees and 0, and then 360 degrees and 1. Okay, and now I like to apply the transformations to each of these points. So I know that the amplitude is going to change to √5, so instead of 1s and -1s, I'm going to have √5 and negative √5. So I'm almost going to ignore that for now and focus on this, because this is really where there's a bit of a kicker. So the question is, what value do I need to put in here so that I get an output of 1? So what is the new alpha value that is going to replace 0, right? So I'm just going to solve for that real quick. 2 alpha minus 26,5 whatever equal to 0. So that's going to be 2 alpha is equal to 26,5. Oh. And so alpha is equal to that divided by 2, which is 13,28 something. Okay, right, so this is telling me that I'm now going to have this point over here, and the x will be 13,2 whatever, and the y coordinate will be √5, right? Because the amplitude is no longer 1, the amplitude is now √5. Okay, and then the next question is, okay, who is the new 90 going to be? So we repeat the same process, except now we ask ourselves, okay, which input is going to give us the same result as 90 would have in this original guy? So that will be 1. Wow, there are strange sounds happening upstairs. Why? Okay, so that's gonna be alpha plus 90 divided by 2. So that's going to be 58,2 whatever. Okay, and the y coordinate will still be 0. Okay, and then from here it's pretty clear what's going on. So from 13,2 to 58,2 is 45 degrees, which makes sense because the periodicity has been halved. So on my original cos graph, from this point to this point we span 90 degrees, so it makes sense that now from this point to this point we're going to span 45 degrees instead, half of that. So we can use that to quickly work out the rest of our coordinates. So that's going to be another 45 degrees. It's going to be 98,103,2, and this will be negative √5, and then from there another 45 degrees, so that's going to be 148,2 degrees and 0 as the y coordinate, and then from there another 45 degrees, so that would be 193,2 blah 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 and √5. Okay, right. Um, and from here to here, we should be traveling 180 degrees because that's the new period. Right, and so it goes something like that. Okay. So, and we can double check these things for sure. Let's take our alpha, our 26,56, what? Oh, and divided by 2 to get the 13,2, what? And add the 90. So, wait, this is the point I was trying to get at, this x value. If we put this x value into this function, we should get an output of negative root 5. So let's see. Sanity check. Right, and we do indeed get something that was initially alarming, but that is indeed negative root 5. If I divide this by negative root 5, right, so that is to say that that big decimal and negative root 5 are the same number. Okay, right, so we are on a good path here. We don't even need all of that agony. We don't even need all of that agony because we don't even need this. We just need the maximum. Oh. Okay, so all we needed really was the fact that this expression hits a maximum value of root 5, minimum value of negative root 5. So anyway, it was a fun endeavor to have a look at how you can go about sketching a graph where there's both a horizontal translation and a periodicity chain. Anyway, but I am going to move this because it is obfuscating the point. Okay, so maximum value is root 5, right? So that is the maximum value of this, okay. So let's just make that abundantly clear. Maximum value of this expression is root 5, right? And so the maximum value of this bit, which is what we were concerned with to begin with, right? The maximum of that is just going to be 2 more than this. So it's going to be root 5 plus 2. Interesting question. And we do agree answer-wise, so that's perfect. Definitely curious about the different ways, the different approaches to this question. So I'm going to dedicate a bit of time to follow along with the memo. Did I just take something that belonged somewhere else? Sort of. Okay. Let's see what you have to say, guys. So, there's three alternatives that are given, which is very exciting. First one, we rewrite. Okay, so we rewrite this using the compound angle identity, which is what we did. Okay, so the first approach is the way that I went about it initially. So we agree as far as deriving these equations, right? How we arrived at them. Then the solving is where it becomes interesting. So they square this one. Okay, so this is actually really interesting. So I'm just going to copy this. Yo, this is where it becomes tricky, trying to move these things and they refuse to move. Okay, so then they square, so r squared cos squared beta is equal to 4, and r squared sine squared beta is equal to 1 squared, right, which is 1. And then they add them together, so r squared cos squared beta plus r squared sine squared beta will then be equal to 4 plus 1. Well, factor out the r squared, so then we're left with cos squared beta plus sine squared beta is equal to 5. Then cos squared beta plus sine squared beta is just the same as 1. And so our r could be positive 5, could be negative 5, but we're told that r is greater than 0. So actually, hang in there, iPad, r will only be the positive square root of 5. So I'm guessing because of the squaring, that's how they introduced the possibility of a second solution, whereas we went a division route. So it was a division of linear terms, so there wasn't any introduction of a possible new solution. What I mean by that is, if you're told that x is equal to 3, I mean, this is silly. If you then say this is the same as saying x squared is equal to 9, when you try to go back to figuring out what x is, because of the squaring, you've introduced the possibility that x could be negative 3 as well. Like, that also solves this equation. So you would have to have an explicit condition that tells you that x is definitely positive in order for you to say exclusively that x is equal to positive 3. Anyway, so that's the first approach, which is cool. Let's look at the second approach. So second approach starts out the same way, and then from there, okay, so the second approach is our approach, where we divided the one equation with the other in order to get a tan equation, and then from there we got our solution. Cool. And then the third alternative looks very tasty. What? What is happening right now? Hey, I'm seeing something about x squared plus y squared. Watch off. I am so confused. Okay, let me just read it out loud. Okay, so we start out with what we were given. Okay, so just gonna duplicate this again. Okay, So they start out with this. Then they divide through by the r. So we end up with 2 over r cos 2 alpha plus 1 over r sine 2 alpha, and here we have cos 2 alpha minus beta. Okay. Then we have x squared plus y squared is equal to r squared. Eba. 2 squared plus 1 squared is equal to r squared. Why? Why is that the case? So I mean, cos 2 alpha, we don't know what kind of angle 2 alpha is, but let's just suppose it's an angle in here, right? Doesn't really matter where it is. So there's going to be some length r, some coordinate x, y, where that line ends. So cos 2 alpha is x over r, and sine 2 alpha is y over r. I don't understand x squared plus y squared bangenapi. I mean, it's to do with that little triangle for sure, but how do we know what is 2, what is 1? Yeah, no, I don't know. I don't know what the memo means. I don't know what the memo means. If anyone understands the third approach in the memo, yo, holla. Listen, holla. And just explain what is the meaning of this x squared plus y squared is equal to r squared. Where are the 2 and the 1 coming from? I need to know. Okay, anyway, it's been good. This paper was fun to work through. Yeah, looking forward to starting the next series where we're going to look at the department's paper from last year, 2023, end of last year, which was finally released. Whoop whoop. So excited to sink into that. So yeah, catch you then.